So I had a dumb idea, and I'm going to talk about it. I'm Steve. It's important for this talk that I tell you a little bit about my background. So I've been at YouTube on the player infrastructure team for 8 years, and that's it. That's all I've done in the video industry. I've just been at YouTube. And I tell you this is relevant because I've seen a lot of what YouTube's done, but I have not seen the wider field firsthand. I've definitely, been a part of it as part of this community, and I've learned a lot. But so my experience is limited. Also, one time I did train a machine learning model on a GPU, so I am a machine learning expert. When at YouTube, we try to build things that are scalable, robust, and rich in that order. So scalable matters the most because, if we can't provide the service to everybody, that's going to interfere with how robust it is. And robustness matters to us a lot. When you press play, it should play. So that's very important. Richness is in terms of feature richness, quality, anything like that. All of those features are things that we do strive for, but we strive for them subordinate to the other ones. And this has gotten, hitting all three of those consistently with decade-plus code bases has gotten kind of whiffy. So for instance, we've been working on gapless. Gapless just sort of launched recently. And it took maybe longer than it should. People seem to agree with that. Google Play Music already had it, just copy the code over. And when Carson from online owns you that bad, there's only one response. No, but seriously, we wanted to reevaluate some of the things that we were doing and try and figure out, is there something fundamental that we can do differently? Knowing that we have this great obligation to continue to serve everybody who wants to get access to this media. We have had some dumb ideas. So let's think about how the dumb ideas that we've had in the past have influenced things. So one problem that we've had is that playback initialization is slower than we'd want it to be. Our dumb idea here was skip fetching the manifest. Instead, go straight to fetching video bytes. So we built this thing, it's called Onesie. And I didn't pick the name. Onesie is a system where the player sort of constantly knows which CDN region to talk to, and it goes and picks a node in that region. It asks it to provide metadata for initial format selection, and then also locality within the node of which thing to use. And the CDN will immediately return, it'll generate a nonce, encrypt the media bytes with that nonce, and send it down immediately, so we can start buffering right away. In parallel, it goes back to the data center, does all the normal checks that we would need to do inside a data center, make sure the user's authorized, make sure that the video is public, or if it's private, that they're in the ACL, all of that stuff. And if that check comes back, the CDN will pass down the decryption key, allowing the player to consume the media right away. And so it also can do a bunch of extra metadata checks, maybe some edge compute to do that playback initialization, and then we can proceed into a standard dash playback from that point forward. So that's pretty great. It's an API for playback initialization, and we've used it to great effect. It has decreased latency significantly. We had another problem, which is that we support ultra-low live latency streaming. And the manifest, just getting, our CDN's pretty fast because once you know a thing to ask for, you can just ask the CDN to stream it to you and it will go up the chain and grab it. But actually getting the manifests on time turns out to be a bit of a challenge because our CDN's not built for dynamic things, so we host our manifests centrally. So here's a dumb idea. What if we don't fetch a manifest? You'll note this is the same dumb idea, but in a different form. So we built a protocol, it's called manifestless live. Basically, the CDN knows the latest segment that it has served, and a new client can go to the CDN and ask, give me that segment, whatever the latest is. And then that's, if you want the next segment, you just request one higher number, and the CDN will go and do a hang and get, and then spew that data back out to all of its clients. Pretty simple. The eMessage atom, which is a standard part of CMAF, contains enough metadata to replace a manifest functionally. It contains everything that you'd need to supply in a manifest. So players that are aware of it can parse this out of the file. Players that aren't aware of it can just use standard dash. So this, you could consider it a protocol for live streaming. Protocol's a big word for what this is, but it's in the neighborhood. Now there are some problems with manifestless live. particularly around initialization and security. There are problems with everything, so like this is a scoped conversation. But when we go to the CDN, because it's not a database, we can sometimes end up with a race condition where we get different SQ values for our initialization. And so the player has to resolve those. Sometimes the player just has bugs around here because you have to adjust the point at which you start playback dynamically once you receive this. And it's not particularly hard, it's not technically challenging, it's just one of those things that bites us every now and then. Similarly, when we're going to do a seek, sometimes we get chunks that are a length different from the standard length of the stream. So it might be 300 milliseconds for one chunk, and that throws off our seeking algorithm. So we have to do this binary search with intuition about where to start. And that takes, normally it's one shot, sometimes it's not. And then if you have something like a network timeout in the middle of your search algorithm, we, again, just get random bugs. It's not a technically sophisticated problem, but it's one that bites us. And so what if we already have a thing that isn't supposed to do manifests, and why isn't that thing just performing these functions for us? And the answer is really sad. It's because code coverage isn't 100% for either of these features. We still have new features that are coming out that depend on manifest full playback. We still have new clients coming out that don't do onesie 100%. And so you can't build a feature on top of these other features that we haven't launched to 100% of clients, because we have this super long tail going back years of users who are on older clients. That's incredibly frustrating when you're just doing the same thing twice and ending up in the same situation multiple times. And more importantly, like, it actually compromises the fundamental goals that we want to deliver. Not just richness, not just the time it takes to ship features, but like if we're still maintaining manifest servers, but not at 100%, then the rarer features that go down can go down and take down the manifest servers. And because like not all of our SRE's eyes are focused on this one way of serving, the diversity just really gets to us. And fundamentally, we think that that diversity is about client update speed, which is kind of a surprising result. But it's one that we've seen over and over again. When it takes weeks to cut a client release and get it deployed to a sufficient number of people to run experiments, and when it takes months for a bug fix to come out and reach most of the user base so that you can drop old code or delete a workaround from your server, it just ends up being that new features take years. And this has really hurt us. Now, there's a technology that some of you may have heard of that allows us to push code dynamically. This is not a terribly surprising result. So here's a dumb idea. Let's put JavaScript inside of our native apps. This is a relatively contained application of JavaScript. We're not rewriting our entire player code or client code in JavaScript. We're just doing a small chunk, the chunk that basically you would find in any in -JS, the amount of code in that window. So not UI, but like build a media source-like interface within Android where you can plug in your media and build a Coronet library that allows you efficient access, maybe lower level access than you'd find from the web, which needs to do a bunch of security things in order to keep the web model working. But all that is wrapped up in JavaScript. And this is like honestly not even enough of an idea to talk about because it's just a browser inside your app. So like you can already do this with a web view. So let's not talk about that. Let's talk about what the consequences of this thing are. So I'm going to be a thought leader for a minute and ideate on the potentialities unlocked by this approach. So YouTube is a vertically integrated direct-to-consumer cloud service provider that's not leveraging its unique infrastructure. And it comes down to not having embraced the full potential of how a playback is a playback. I mean, our playbacks aren't Dash. Our playbacks are computations. And the potential we have is to make playbacks into distributed computations. And if you're thinking, who is this guy? Visionary former CEO of WeWork, Adam Newman? No, I told you, I'm a machine learning expert. I am a machine learning, and I'm serious about the computation thing, but let's not get stuck up on highfalutin terms like that. The way I am a machine learning expert today is that I spend most of my time cleaning up bad data. As any real machine learning expert will tell you, this is most of what they do as well. And this is really important even to answer basic questions of moving things back and forth. So let's say for whatever reason you wanted to do ABR on the server. And you don't just want to do this because you're stuck in a time that 2 decades ago where clients didn't have enough math to do this. But you want to do it because you have some interesting new approaches, like for example Stanford's Puffer experiment, where they actually gather a bunch of telemetry, merge client and server information, and then do model selection on the server. This not necessarily, it doesn't really matter where you run client or server information, but for practical reasons, you might choose to do it at one place or the other. You don't get that choice today because of how we've implemented our algorithms. But if you were going to do it, then you would need to make sure that your client telemetry is correct. So I want to do a little audience participation. Please stand up if you work on a quality of experience project that gathers data from multiple platforms. Anybody? All right, can we get a round of applause for these heroes, these absolute legends? Thank you. Now, raise your hand if all of those produce consistent data. Is that anyone? That's no one? Okay, yeah. So let's say you want to implement a simple feature in your ABR algorithm. Downgrade when you drop frames, right? Easy. So here's the high-res visualizer returns. The blue line over there this is a time series chart. I'm not going to explain all of it. We don't have time. The blue line in the third column is the number of frames decoded. These red bars are the number of frames dropped. The middle one is buffer health. And this top line is playback state with green being playing, red being buffering. And so we see in this example that a little bit of network trouble ends up causing dropped frames later on. Drop frames have nothing to do with network trouble. So what's going on here? In this case, Chrome has more audio than video to play out. And so when the video runs dry, the audio moves forward, the clock freezes at the point where it rebuffers, and then when you append more video later, that video comes in and needs to be dropped to catch up with the audio clock. So if we're downgrading, then a user might, for a little bit of network trouble, we might assume that a user can't play 720p and lock them out of their account. We also see that just moving into and out of the background causes bursts of dropped frames for no reason. Some playbacks, on some browsers, if you put something into a browser tab, it will decode and drop every frame. We also find we find that the ideal situation where you can start a playback, immediately see that you're dropping a ton of frames and then downgrade, like this is an example of it. It's such the minority case. When you try to use a feature like drop frames just based on drop frames alone without much tuning, you end up with so many corner cases where your signals lead you astray and you bump yourself off the correct path. Then, of course, there's the crazy moments where in this case, we see that the issue at hand isn't even related to drop frames. A user is having a real performance problem. We should downgrade for them in an ABR algorithm. But their buffer health is totally fine, which why we know it's performance. But we see very few actual drop frames. Instead, what we're seeing is the frames aren't getting decoded at all to such a point where Chrome actually has to stop playback in order to allow the player to catch up. So if you have an algorithm and you decide one thing I'm going to return from my client is the number of dropped frames, you will entirely misread this performance problem and then keep sending the wrong format. Now, of course, the only way to deal with all of these problems is like really intensively look at them and then build workarounds for the data analysis. But if you build that on the client, it's at least tractable because you can do things like check the visibility. You can check the player state when you're integrating your signals. If you try and do this on the server, I don't know how you do it. Like you'd have to interpolate from any signals that you have. You have to infer a bunch of data. And if you have to do this for every time you need to fix any client bug in the field, you will lose your minds. You will lose your staff. We actually, secondhand information, but like this was involved in the collapse of one major company that did this in 2000s. It's like they just built everything on the server, and ultimately the combinatorial explosion really got to them. And so there's a very simple principle that I think everybody will agree with, which is that problems are easier when they're more local. You should do client work on the client. You should do server work on the server. And because I know everybody is absolutely with me, we should proceed right on to the logical conclusion of that, which is that we should get rid of all video protocols. There's a weird thing that happens in video protocols. And I'm speaking particularly about the more modern incarnations that are designed for CDN scaling, like Dash and HLS, which is that they're a little bit asymmetric. So here's an extremely dumb diagram. I'm sorry I didn't have time to hand draw slides this year. But let's say we're running a browser on one side with media source on one end and a network stack on the other, JavaScript in the middle for computation. Let's say we're running C++ on the other side on the server with a network stack on one time, a disk and video stack on the other, dealing with established protocols like, say, an MP4 file. you have these symmetric pairs that make it really easy to produce incredibly rich, incredibly flexible architectures, such as a bitstream spec for video. It doesn't really, it's nice and layered. It's exactly at one point. You have HTTP and then hopefully QUIC or HTTP3 as we move towards those. And those allow us a lot of flexibility in how we structure our applications. But for video, we keep sticking to this weird line in the sand right in front of a CDN. And it's not that weird because we know it was designed for how CDNs were built 10 years ago. But here's a fun question, is are we continuing to stick to that in principle? If you look at HLS, it's basically just a file format. It's ideally suited for CDN behavior. Now, Apple's low latency HLS proposal takes that and moves it a lot more towards an interactive application. But we're still specifying it as if it was a file format protocol. We put it in that place. We don't really build a toolbox for people to build video protocols that are extensible, that suit the needs of an individual company, that make sense given a person's database layout. It's very narrow. And the idea would be that if you have the ability to version code at the same time, then that's implicitly your specification, right? This is how apps work. They talk to a server that's running relatively the same version. And at that point, you gain a tremendous amount of flexibility for what actually passes over that pipe in the middle. And I'm not saying that interoperability is bad. I'm saying that we might be making the wrong things interoperable. So what if, I know this is crazy, but what if a cloud provider offered a way to run computations at the, I'm talking about Lambdas. And of course, Lambdas a lot of times are running in JavaScript or whatever. So we might need a few specific primitives, such as being able to suck data out of a pipe and then shove it in without involving the Lambda itself in a computation. Certainly, this is how our C++ servers are written, is performance doesn't matter for most of the code, and then there's a very small amount of code where performance is absolutely essential. And you can just architect that out depending on how the standard works. Now, that's not exactly how we're going about this. We're definitely sticking to our server full approach, where we're just sort of by hand making sure that our release processes are going to be tightly coupled between our JavaScript implementations and our server code. And we're also using a bunch of standard technologies such as just HTTP over QUIC for delivery. We're using a relatively simple response framing where we just have a few bytes of header data that identify a part segment, and then some metadata. And if you need to do something more complicated, like an RPC, you can just use a protobus, and oh my God, we've reinvented RTMP. Which, that's entirely true, and I think that's kind of the point here, is that this isn't really revolutionary in any way. I told you it was a dumb idea at the start. It's a very mild change in how you build, how you use existing pieces of infrastructure. Basically, this is just Dash with a new metadata return channel, which even that is not a new idea. The particular architecture for it, I think, has some wheels. But the thing that this lets you do is just move. We're client heavy, so we're going to move some pieces to the server where it makes sense. If you're server heavy, you move some pieces to the client. But you don't have that flexibility in a lot of architectures because of that weird line in the sand that we drew to accommodate CDNs that's no longer particularly relevant. So what are we going to do with this? The first easiest thing that's actually going to be incredibly helpful is that when a server is at past capacity, that we're going to kick in and the client will request a format, and we're going to say, sorry, I'm too busy. I'm going to give you a lower format. It's not load shedding by moving to another server, which will constrain your ingress links, which can actually, at a YouTube scale, can cause problems because you're congesting the very thing that you'd use to solve the congestion problem. You're using a little bit of nudging down to a lower format for users that haven't expressed any indication about video quality. And a user can just override this setting. But for most users, 480 and 720 for one video won't make that big of a difference. When it's in aggregate, it makes a huge impact on our ability to serve on our most load-constrained servers. So that's an immediate benefit. Obvious deviation from the Dash protocol, but very easy to write. You just do a tiny bit of edge compute and then have a way to return the information that you tell the player, you asked for this, but I'm actually going to send you that. You can conceive of other ways to do this, obviously. Again, none of this is new ideas. The question is, how do you structure that in a way that's scalable and sustainable, where you don't keep having to burn yourself down when you add new features like this? Another thing that we're going to do is for ultra-low live latency, making a separate request for less than a kilobyte of audio at 1 second per second costs a lot more resources than it needs. So what if we just interleave the audio again? Well, we wouldn't be remuxing, we'd just be shoving the packets in directly, much like RTMP. You could change the way that you do GOP sizes so that you do you would just join latency by having a single server-controlled algorithm that says when you're this far from head, instead of joining at the segment that you were going to join at and seek into the correct position, you just wait until the next segment comes along, making intelligent trade-offs just based on whatever policy choices that you make, with a lot of flexibility based on the stream type, based on the load. You can do all of that. You can even do more ambitious things, like what if you wanted your high-res client bandwidth information to use a pretty sophisticated machine learning model, one that maybe doesn't fit on the client. Well, you can just send that up, and you can actually merge it with server-side information when you do that. One of the things that's always bothered me is if you actually look at playback traces spanning hours, you can often see cyclical patterns that are very obvious to users because they'll experience rebuffers periodically. Every 15 minutes, their Wi-Fi router changes channels. And so for 30 seconds, they'll have a complete network cutout. But to almost all the bandwidth algorithms that we use, they don't have a history long enough to actually take advantage of that. So what if you took the data and put it into a recurrent neural network that was capable of backtesting, and then it created a compressed token and send it down back to the client so that the server remains completely stateless, but the client can have this extremely long-running piece of information. And yeah, that's too complicated. It's a dumb idea. But that's the kind of thing that you could express much more elegantly if you just have an API for it, which is not something that we really get today with Dash or with HLS. But it is something that you could do with a little bit of edge compute. Now, again, I want to super stress that none of this is revolutionary. We didn't invent anything here. But I also want to say that I think this permutation has a lot of value. And I don't see it being explored. I mean, we've actually heard several talks touching the edges of it today, and we will hear more of how edge compute, how a standardized format for building those servlets will allow us to change the way video streaming is done. But I think we should lean into it because I really think that we're underestimating what the benefit could be of this. And I think that it would change the shape of the ecosystem incrementally, but in a way that I think is very durable. So that's it. Thank you.